Hey everyone, today we're doing lesson 2-4B, solving equations with variables on both sides. We did that in our previous lesson, but today you might encounter something you have not seen before. Okay, I have an equation here, 10x plus 12 equals 2 times 5x plus 6. So that's what 10x plus 12 would look like. And here's one group of 5x plus 6 and another group of 5x plus 6. Let's try to solve this, see what happens. Well, the first thing I would like to do is distribute. 2 times 5x is 10x. 2 times 6 is 12. So I have 10x plus 12. Are you starting to see what's unique about this? So on both sides of the equation, I have 10x plus 12. Normally, when we have variables on both sides, we say, let's go to the bigger party. Well, we don't have a bigger party. So I'm just going to subtract 10x from both sides. This cancels out, and I get 12 equals 12. Well, that's kind of weird. Now, students sometimes start thinking, oh, well, x equals 12 then. No, I don't have an x here. It's just saying 12 equals 12, which is true. 12 does equal 12. What we have here is something called an identity. That means if you remember the identity property, that's kind of like looking in the mirror, both sides of the equation are the same. 10x plus 12, 10x plus 12. It's the same. It's called an identity. And if you have an identity, the equation has infinite solutions. No matter what number I put in for x, they'll equal. I could put a 1 here. If I put a 1 here, 10 times 1 is 10, plus 12 is 22. If I put a 1 here, 5 plus 6 is 11, times 2 is 22. But if I put a 2 in, 10 times 2 is 20, plus 12 is 32. If I put a 2 in over here, 5 times 2 is 10, plus 6 is 16, times 2 is 32. It doesn't matter what number I put in, it will always equal, which means I have infinitely many solutions to this. When both sides of the equation are the same, or when you go to solve it and your x's disappear, so you don't have an x equals anymore, and you get a true statement, 12 equals 12, then you know you have an identity. Let's look at our next example. Clear my screen. Again, I have to distribute. I end up with 4x plus 2 equals 4x minus 5. So you'll notice on both sides of the equation, I have 4x. Here I have 4x minus 5. And over here, I have two groups of 1x plus 2. If I subtract my 4x from both sides, they cancel out again. It's like I get rid of these x's here, and I get rid of these x's, and I end up with 2 equals negative 5. Well, does 2 equal negative 5? No, that's not a true statement. 2 does not equal negative 5. So when you end up with a situation like this, it's not true. You end up no variable and a false statement. Negative 5 does not equal 2 ever. So this equation has no solution. No matter what number I put in for x, I cannot get it to equal. There's no solution to this. So in our next examples, you're going to have to figure out if each problem has one solution, no solutions, or if there's infinitely many solutions. Let's take a look. First one, I want to start with distributing. 1/2 times 6, 1/2 times 4a. Well, 1/2 of 6 is 3, plus 1/2 of 4a is 2a. Now on this side, I can combine my like terms. I have 6a, and I have negative 4a. Negative 4a plus 6a is 2a. Add 3. Now if I look at this, 3 plus 2a, 2a plus 3, these are equal. They are exactly the same. It's an identity. I could go one step further and subtract 2a from both sides. And I will end up with 3 equals 3, which is a true statement. I have no more variables left, and I have a true statement. Therefore, I have infinite solutions. Let's try my next example. I didn't clear my screen. I'm terrible at that. Let's try the next one. 3 times 4x, 3 times 2. 12x plus 6 equals 16. I have to distribute again. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. I have some like terms I can combine. I have 16 minus 10. That will give me 6 minus 2x. And on the other side, I have 12x plus 6. You can see right now already that I have 12x on one side and negative 2x on the other. So this is not an identity. It's also not a no solution situation because my x's aren't going to cancel out. I'm going to go to the bigger party. I'm going to add 2x to both sides. I have 14x on one side plus 6. I have 6 on the other because this canceled out. I'm going to subtract 6 from both sides. And I get 14x. 6 minus 6 is 0. I lost my minus there. So now divide by 14. And 0 divided by anything will still be 0. Now sometimes students look at that and think that means there's no solution. That is not correct in this case. The answer is actually x has to be 0. That is a solution. If I put a 0 here, 4 times 0 is 0, plus 2 equals 6. 0 plus 5 is 5. 0 plus 5 is 5 times negative 2 is negative 10. 16 minus 10 is 6. I get 6 on both sides. So my answer is x equals 0. It is one solution, and that is my solution. Next example, I have all sorts of like terms to combine. This is where it's not always obvious if you have a no solution or infinite solutions. Negative 7n plus 8n gives me 1n, or just plain n, plus 8. On the other side, I have 2n and a negative n. 2n minus an n gives me 1n plus 6. Well, you can already see I have 1n on both sides. When I subtract n from both sides, my n will go away. So it's either going to be infinite solutions or a no solution. So then you ask yourself, does 8 equal 6? And no, 8 does not equal 6. That is not a true statement. Therefore, there are no solutions to this. Just think about it. Is there any number that if you add 8 to it will be the same as taking the same number and adding 6 to it? It just doesn't make sense. So 8 does not equal 6. Therefore, there is no solution, which we can often just write NS, no solution, if my pen wanted to. I press that button again. You've seen me do that before. NS. I don't know under what circumstances that happens. Okay, let's look at another example. 7m plus 16 minus m. Well, I get some like terms. 7m minus m will give me 6m. Plus 16. And on the other side, I need to distribute. So I have my 10m. And negative 4 times m is negative 4m. Negative 4 times negative 4 will give me a positive 16. Combine my like terms. 10m minus 4m will give me 6m plus 16. Now you can already see this is an identity. On my left side, I have 6m plus 16. On my right side, I have 6m plus 16. I could take it a step further and subtract 6m from both sides. And I get 16 equals 16, which is a true statement. My variables canceled out. So that means no matter what I put in here, and again, it makes sense. If I take any number, multiply it by 6, and add 16, I will get the same as any number multiplied by 6 and adding 16. So it doesn't matter what number you put in there, you'll always get the same answer. So again, this is an infinitely many solutions. So we'll just put IS for infinite solutions. Let's give this one a go. Feed the birds, or in other words, distribute. Negative 4 times f is negative 4f. Negative 4 times negative 2 is a positive 8. And don't forget, I have a 13 at the front. I want to see if that equals negative 3f. We're going to get one solution, no solutions, or infinite solutions. Let's combine like terms. 13 plus 8 is 21 minus 4f equals negative 3f. Okay, I have negative 3f's over here. I have negative 4f here. They're not the same, so I don't have an identity or a no solution situation. I'm going to go to the bigger party. Negative 3 is bigger than negative 4, so I'm going to add negative 4. I'm going to add 4f to both sides. And I end up with 21 equals 1f, or just f. So I have one solution, and that's it. One more. Negative 9c plus 10c will give me 1c, which I can write as c plus 12. On the other side, half of c is 1c. Half of negative 24 is negative 12. Okay, so you can see I have a c here, c here. If I subtract c, I end up with 12 equals negative 12, and we know that 12 does not equal negative 12. Therefore, there is no solution to this. There's no situation you can think of where you take a number and add 12, and it will be the same answer as if you take a number and subtract 12. It doesn't work. So, what do you notice about the equations that are no solution or infinite solutions? You should notice that the coefficient in front of the variable is exactly the same on both sides, so that if you subtract it, you will get the same. They'll cancel out. You'll get no variable left. So in summary, there are three types of solutions when solving an equation. One solution, the variables don't cancel out. No solution, the variables cancel out, but you're left with a not true statement. Or infinite solutions, where the variables cancel out and you're left with the true statement. That's it. Have a great day.